Have you ever found yourself wrestling with a piece of code that just won't behave as expected? In the vast and intricate world of programming, this scenario is all too familiar. You've written a piece of code, you've done your best to make sure everything is in order, but when you hit run, things don't go as planned. That's where the concept of debugging comes in. Debugging is the process of identifying and fixing errors, or bugs, in our code. It's a fundamental aspect of programming, an art in itself, and sometimes it can be a real head-scratcher. But fear not, for there's a powerful weapon in a programmer's arsenal designed to combat these elusive bugs, the debugger. A debugger is a software tool that allows us to inspect our program's execution, step through our code, and identify issues lurking in our source code. If you've ever found yourself in this situation, then a debugger might just be the tool you need. So what is a debugger anyway? Well, it's an invaluable tool in a programmer's toolkit. A debugger is a software program used to test and debug other programs. This testing is done by monitoring the execution of the program, allowing the programmer to track and control its operation. In essence, a debugger is like a magnifying glass for code. It allows programmers to zoom in on individual lines of their code, step through them one at a time, and observe how the program behaves. This fine-grained control and observation are what make it such a vital tool for programmers. The primary function of a debugger is to help programmers find and fix bugs in their code. A bug is an error or flaw in a program that causes it to produce incorrect or unexpected results, or to behave in unintended ways. Bugs can be as simple as a typo in a variable name, or as complex as a memory leak that only occurs under very specific circumstances. A debugger works by allowing the programmer to pause the execution of the program at any point and inspect the current state of the system. This includes the values of variables, the program's call stack, the contents of memory, and more. By examining these details, the programmer can gain insight into how the program is operating and where it might be going wrong. In addition to pausing and inspecting the program, debuggers also often provide features for controlling the execution of the program. For example, a programmer might set a breakpoint at a particular line of code, causing the program to pause every time it reaches that line. Or they might step through the code one line at a time, watching how each line affects the state of the system. It's important to note that while debuggers are powerful tools, they are not a magic bullet. They can help you find where a bug is happening, but they can't tell you why it's happening or how to fix it. That part still requires human intuition and expertise. Now that you have a basic understanding of what a debugger is, let's delve into its features. Let's start with the basics, shall we? The first feature we'll talk about is breakpoints. Breakpoints are markers you set in your code. When the program runs and hits a breakpoint, it pauses, giving you a chance to inspect the state of your program at that very moment. You can check the values of variables and see exactly what's happening inside your program. It's like taking a snapshot of your program's execution. Next, we have step-by-step execution. This is a feature that allows you to move through your code one line at a time. You can execute each instruction individually and watch how the state of your program changes with each step. This is particularly useful when you're trying to understand the flow of your program or trace the source of a bug. Now, let's talk about variable inspection. This feature lets you keep an eye on the values of specific variables while your program is running. If a variable's value isn't what you expect it to be, it might just be the clue you need to find that pesky bug. Last but not least for today, we have watch points. These are similar to breakpoints, but instead of pausing when a certain line of code is reached, watch points pause the program when a specific variable or memory location changes. This is especially handy when you're trying to figure out why a variable isn't holding the value it should. Each of these features brings something unique to the table. Breakpoints allow you to freeze time and take a close look at your program's state. Step-by-step execution lets you follow your code's path like a detective on a trail. Variable inspection is like having a microscope that lets you zoom in on the data in your program. And watch points? They're like alarms that go off when something in your program changes. These features allow you to control and inspect your program's execution in a granular way. By understanding and using these tools effectively, you'll be well on your way to becoming a master debugger. But that's not all a debugger can do. Let's explore some more features that make a debugger an indispensable tool for programmers. Among these, call stack inspection is a key feature. During debugging, you might want to see the sequence of function calls that lead to the current point in your program. The call stack inspection feature provides this information, helping you trace the path your program has taken. Next, we have memory inspection. This feature allows you to examine the contents of memory at specific addresses. This can be incredibly helpful when you're dealing with issues related to data that's stored in memory. For instance, if you suspect that a memory leak is causing trouble, memory inspection can help you confirm your suspicions and locate the problem. Then there's expression evaluation. This handy feature lets you evaluate expressions during runtime. Say you want to check whether a particular condition is true at a certain point in your code. You can use expression evaluation to do just that. This can be especially useful for testing hypotheses about what might be going wrong in your code. Finally, let's talk about conditional breakpoints. You already know that breakpoints can pause your program at specific points, but did you know that you can set these breakpoints to trigger only under certain conditions? This is what conditional breakpoints do. Let's say you only want to stop the program if a variable reaches a certain value. Instead of stopping at every iteration, you could set a conditional breakpoint that only triggers when this value is reached. This allows you to focus your debugging efforts on the specific scenarios that are causing issues. These are just a few of the additional features that debuggers offer. By leveraging these tools, you can delve deeper into your code, understand its behavior, and identify bugs more effectively. Remember, a debugger is not just for fixing errors, it's a powerful instrument for gaining insights into your code and for refining and improving it. With these features, you can gain a deeper understanding of your program's behavior and pinpoint issues more accurately. Ready to take your debugging skills to the next level? Let's dive into some advanced features that can truly supercharge your debugging game. Source code and disassembly views are incredibly useful. They give you a dual perspective, showing you both your high-level code and the corresponding low-level instructions. This way, you can understand how your code translates into machine language, which can be crucial when dealing with complex bugs. Next up, we have stepping into, over, and out of functions. Stepping into a function will take you to the first line of that function. Stepping over, on the other hand, runs the function without going into it. If you're already inside a function, stepping out will complete the current function and pause at the next line of the calling function. These features give you granular control over your debugging process. Now, let's talk about profiling. Some debuggers come with built-in profiling tools, which can analyze your code's performance. With these tools, you can identify bottlenecks in your code, helping you optimize it for better performance. Lastly, there's core dump analysis. This is particularly relevant in low-level programming, where debuggers can analyze memory dumps generated when a program crashes. This gives you a snapshot of the program's state at the time of the crash, aiding you in pinpointing the issue. Now that we've covered some advanced features, let's look at some of the most popular debuggers out there. There's GDB, or the GNU debugger, a versatile tool that supports a wide range of programming languages. WinDG is a powerful debugger for the Windows platform. Visual Studio Debugger, integrated into the popular Visual Studio IDE, provides a seamless debugging experience. And then there's LLDB, a high-performance debugger designed for large code bases. Whether you're a beginner or an experienced programmer, these debuggers can help you squash those pesky bugs more efficiently. The choice of debugger, of course, depends on your programming language, platform, and development environment. But with these advanced features at your disposal, you're well equipped to tackle any debugging challenge that comes your way. In conclusion, a debugger is a programmer's best friend. It's more than just a tool to fix bugs, it's a powerful instrument that helps developers understand their code better. From setting breakpoints to inspecting variables, a debugger allows you to pause and inspect your program at any point during its execution. It gives you the power to step through your code one line at a time, so you can see exactly what's happening and when. With advanced features like watch points, you can monitor changes to specific variables or memory locations. And let's not forget about the power of conditional breakpoints, profiling tools, and core dump analysis. These features help you to focus on specific scenarios, identify performance bottlenecks, and understand the state of your program at the time of a crash. Remember, debugging is not about fixing bugs, but understanding why those bugs exist. Happy debugging!